Welcome to the exciting world of cloud computing, your ultimate destination to learn DevOps, cloud and CI/CD solutions. Get ready to level up your skills and dive into the world of new technologies. This is Vivek. I'm an AWS certified solution architect professional with 15 plus years of experience in DevOps, cloud, and CI/CD solutions. Today we are going to discuss about AWS VPC, virtual private cloud, and 50 benefits of creating infrastructure in VPC. AWS VPC is a virtual network service provided by Amazon Web Services that allows you to create a logically isolated section within the AWS cloud, where you can launch AWS resources such as Amazon EC2 instances, RDS databases, and load balancers. It provides you with complete control over your virtual networking environment, including IP address ranges, subnets, route tables, and network gateways. When you create a VPC, you define the IP address range for your VPC using CIDR notation. This range determines the number of IP addresses available for your resources within the VPC. You can also divide your VPC IP address range into multiple smaller subnets, which are subsets of the VPC IP address range. Each subnet can be associated with an availability zone, which is a distinct location within an AWS region. In a VPC, you can configure both inbound and outbound network traffic using security groups and network access control lists. Security groups act as virtual firewalls at the instance level, controlling inbound and outbound traffic based on rules that you define. ACLs, on the other hand, act as stateless firewalls at the subnet level, allowing or denying traffic based on rules that you define. To connect your VPC to the internet, you can create an internet gateway and attach it to your VPC. The IGW enables communication between instances within your VPC and the internet, allowing you to access resources on the internet and make your resources accessible from the internet. If you want to establish a private connection between your VPC and your on-premises network or another VPC, you can use AWS Direct Connect or VPN connections. AWS Direct Connect provides a dedicated network connection from your premises to AWS, bypassing the public internet. VPN connections, on the other hand, use encrypted tunnels over the internet to securely connect your VPC with your on-premises network. To control the routing of traffic within your VPC, you can create route tables. Each subnet in your VPC must be associated with a route table, which contains rules that determine where network traffic is directed. You can create custom route tables and associate them with specific subnets to customize the routing behavior within your VPC. In addition to the core VPC components, AWS provides various additional features to enhance VPC functionality. These include network address translation, NAT, gateway and NAT instances, which allow instances in private subnets to access the internet while remaining private, elastic IP addresses, which are static IPv4 addresses that you can allocate to your resources, VPC peering, which enables you to connect multiple VPCs together using private IP addresses, and VPC endpoints, which allow you to privately connect your VPC to supported AWS services without requiring an internet gateway or NAT device. Overall, AWS VPC provides a flexible and scalable way to build and manage your network infrastructure within the AWS cloud. It offers a high level of control, security, and isolation, allowing you to create complex network architectures and securely connect your cloud resources with your on-premises infrastructure. Here are 50 benefits of using AWS VPC. 1. Enhanced security. VPC provides robust security features, including security groups, network ACLs, and the ability to configure security policies to protect your resources from unauthorized access. 2. Network isolation. VPC allows you to isolate your resources within a private network, providing an additional layer of security and privacy. 3. Customizable networking. VPC enables you to design and customize your network architecture, including IP address ranges, subnets, routing, and network gateways, based on your specific requirements. 4. Control over IP addressing. With VPC, you have full control over IP address ranges, allowing you to define and manage the IP addresses for your resources. 5. Scalability. VPC offers scalability, allowing you to easily scale your network resources up or down based on your workload demands. 6. Hybrid cloud integration. VPC enables secure connectivity between your on-premises infrastructure and the AWS cloud, facilitating a hybrid cloud environment. 7. Cost efficiency. VPC allows you to optimize costs by defining your own IP address ranges, choosing appropriate instance types and sizes, and efficiently utilizing network resources. 8. Compliance and data privacy. VPC provides a secure environment for hosting sensitive data, helping you meet compliance requirements and implement data privacy measures. 9. High availability. VPC supports high availability architectures by allowing you to distribute resources across multiple availability zones, AZs, ensuring redundancy and fault tolerance. 10. Easy management. VPC offers a user-friendly management console and APIs, making it easy to configure, monitor, and manage your virtual network infrastructure. 11. Application testing and development. VPC allows you to create isolated testing and development environments, providing a safe space for developers to experiment and innovate. 12. Fast and reliable network performance. VPC provides low latency and high bandwidth network connectivity, ensuring fast and reliable communication between your resources. 13. Global availability. VPC is available in multiple AWS regions worldwide, allowing you to deploy your resources closer to your end users for reduced latency and improved performance. 14. Backup and disaster recovery. VPC facilitates backup and disaster recovery strategies by providing options to replicate and restore your resources across different regions or AZs. 15. Collaboration. VPC enables secure collaboration with partners or customers by establishing VPN connections or utilizing AWS Direct Connect for private data exchange. 16. Seamless integration with other AWS services. VPC integrates seamlessly with other AWS services, allowing you to build comprehensive cloud solutions by leveraging the ecosystem of AWS offerings. 17. Compliance auditing. VPC provides logging and monitoring capabilities, allowing you to audit network traffic and track activities within your virtual network for compliance purposes. 18. Reduced infrastructure costs. By utilizing VPC, you can eliminate the need for physical network equipment, reducing infrastructure costs and benefiting from the economies of scale offered by AWS. 19. Flexibility and control. VPC gives you complete control over your network environment, enabling you to customize and configure network settings as per your requirements. 20. Centralized management. VPC allows you to manage and control your network infrastructure from a centralized location, simplifying administration and reducing complexity. 21. Fine-grained access control. VPC enables you to define granular security policies using security groups and network ACLs, controlling access at the instance and subnet level. 22. Network segmentation. VPC allows you to segment your resources into multiple subnets, providing better organization and isolation for different application tiers or departments. 23. Load balancing. VPC supports load balancing services, such as Amazon Elastic Load Balancer, ELB, for distributing incoming traffic across multiple instances for improved performance and high availability. 24. Easy migration. VPC simplifies the migration of your on-premises applications and services to the cloud by providing a secure and flexible environment for hosting your resources. 25. Compliance certifications. VPC is compliant with various industry standards and regulations, such as GDPR, HIPAA, and PCI DSS, enabling you to meet specific compliance requirements. 26. Network monitoring and troubleshooting. VPC provides monitoring and troubleshooting capabilities, allowing you to monitor network traffic, capture flow logs, and diagnose network issues. 27. Application isolation. VPC allows you to isolate your applications within separate subnets, providing independent network boundaries for improved security and performance. 28. Managed NAT Gateway. VPC offers a Managed Network Address Translation (NAT) gateway service, allowing instances within private subnets to access the internet while remaining secure. 29. Secure Site-to-Site VPN. VPC enables secure site-to-site VPN connections, allowing you to connect your VPC with your on-premises network securely. 30. Secure Remote Access. VPC supports secure remote access to your resources by providing options for remote VPN connections, allowing authorized users to access resources securely. 31. Partner integration. VPC allows you to securely integrate with partners and third-party vendors by establishing private connections and controlling access to shared resources. 32. Disaster recovery planning. VPC facilitates disaster recovery planning by enabling you to replicate your resources to a different AWS region or availability zone for resilience. 33. Network performance optimization. VPC allows you to optimize network performance by selecting appropriate instance types, utilizing elastic IP addresses, and configuring routing options. 34. Global networking. VPC integrates with AWS Global Accelerator, enabling you to improve the availability and performance of your applications by routing traffic over the AWS Global Network. 35. Network Access Controls. VPC provides network access control features, allowing you to define and enforce access policies based on IP addresses, ports, and protocols. 36. Compliance Auditing and Logging. VPC offers logging capabilities, allowing you to capture network traffic and log data for compliance auditing, troubleshooting, and security analysis. 37. Resource Tagging. VPC supports resource tagging, enabling you to organize and categorize your resources for better management, cost allocation, and resource identification. 38. Elasticity and Auto-Scaling. VPC integrates with AWS Auto-Scaling, allowing you to automatically scale your resources based on demand, optimizing performance and cost efficiency. 39. Direct Internet Access. VPC provides direct Internet access, for instances within public subnets, allowing them to communicate with the Internet without going through a NAT gateway. 40. Centralized Network Services. VPC allows you to deploy centralized network services, such as DNS resolution, DHCP, and IP address management, for efficient resource management. 41. Compliance with Data Residency Requirements. VPC enables compliance with data residency requirements by allowing you to select the AWS region where your resources are located. 42. Network Encryption. VPC supports network encryption using AWS Private Link, ensuring secure communication between VPCs and AWS services without going over the Internet. 43. Containerized Workloads. VPC supports containerized workloads using services like Amazon ECS, Elastic Container Service, or Amazon EKS, Elastic Kubernetes Service, allowing you to deploy and manage containers securely. 44. API Gateway Integration. VPC integrates with Amazon API Gateway, allowing you to securely expose APIs hosted within your VPC to external clients and partners. 45. Improved network performance for IoT. VPC provides low-latency network connectivity for IoT applications, enabling fast and reliable communication between IoT devices and backend services. 46. Reducing attack surface. VPC allows you to limit exposure to the Internet by placing resources in private subnets and exposing only necessary services to the public Internet. 47. Compliance with Network Segregation Requirements. VPC enables compliance with network segregation requirements, ensuring that different applications or departments remain isolated within separate subnets. 48. Data Transfer Cost Optimization. VPC allows you to optimize data transfer costs between your VPC and other AWS services by utilizing AWS Direct Connect or VPC peering. 49. Improved performance for big data processing. VPC provides the infrastructure to process and analyze large datasets using services like Amazon EMR, Elastic MapReduce, while maintaining control over network traffic. 50. Simplified network connectivity for multi-account architecture. VPC enables simplified network connectivity and resource sharing across multiple AWS accounts using AWS Resource Access Manager and VPC peering. These benefits highlight the extensive advantages of utilizing AWS VPC for building secure, scalable, and customizable network infrastructures in the cloud. Thank you for watching. Please subscribe for more topics.